Hello, everybody. Coming to you live from AdvanceKentucky in Lexington, Kentucky. I am Monique Morton, Senior Director for Mathematics and Computer Science with AdvanceKentucky. And today's office hours topic is AP Calculus BC's parametric functions and what did I call it? Vectors and a motion in a plane. That's what I'm going to generally talk about. I need to close the door, so I'll be back. See, I'm back. So this topic shows up on the AP Calculus BC exam a lot, usually on calculator parts, but it could go on either part. So I'm going to take a few minutes to review. I'm not going to teach you the whole thing, right? So you're not going to know everything you need to know about parametrics and vectors and motion in a plane from this, but you'll get a little refresher, maybe quicker than you normally would in class. And we're going to look at a couple of free response questions, hopefully to better prepare you for the AP Calculus BC exam in May. Oh my God, May is only 2 weeks away. So why don't we get started? I'm going to share my screen here. All right, here we go. And let's start out with like what I call a quick and dirty review. So let's suppose that you were at a point. Let's say that point was here. That's where you are now. Let's name the point P. Well, we normally name points with Cartesian coordinates with coordinates x, comma, y. But what if x and y depended on some third invisible parameter, right, variable, that we call t, because time. So that would make the coordinates of this point, the position, if you will, of this location, be expressed not just as x comma y, but since x and y are functions of t, let's call them x of t, y of t. Now, one of the things we always want to know when it comes to points is not only where you are, but how far you are from where you came from. So let's say where you came from is some point down here that I'm going to call O for origin. And so depending on the path, where you are right now, the distance between these 2 points creates this vector that shows where I started and where I am right now. It doesn't really show how I got there, but that's for a higher level. This is a vector, okay? And we're going to deal with vectors in terms of components. There's a horizontal component, it's horizontal distance x of t. And there's a vertical component. It's vertical component y of t. So that those 2 dashed lines are drew are perpendicular. I hope you're noticing something here. This distance from O to P, let's call it R. R is the length or magnitude of the vector. In fact, we usually say if this is the name of vector R, like R is the name of the vector. I know I just changed what my variables meant, but stay with me. That the absolute value of R is the length or the magnitude of the vector. Well, if you look at this picture, you showed it to somebody who's in Algebra 2, what they'd see is a right triangle, right? And they'd see that the absolute value of R is equal to the square root of x of t squared plus y of t squared. And this is going to lead to some definitions of other things. So this is a quick and dirty relationship. If I express these 2 values of x and y coordinates in terms of a third parameter t for time, I've now created a set of parametrically defined functions that's describing my location in the plane. I can express that location in terms of a vector where x of t is my horizontal component and y of t is my vertical component, and r, the magnitude of t, the magnitude of r, where r is that vector between O and P. Notice that the arrow showed me what direction I moved in. That's the origin, and I ended up there. That length of magnitude can be given to me pretty much by what is the Pythagorean theorem. So here's a quick and dirty review. Now let's talk about what you need to know. So I hope you got a little bit from that, one of them being that parametrically defined function, x of t, y of t, is a function where you have coordinates x and y, or values x and y, that are defined by functions. This A shouldn't be here. Excuse my bad grammar. Defined by a third parameter t, and these are often used to represent vectors on the AP exam. So if you learned IJ notation, for example, if you're doing vectors, that's nice to know, but you don't have to know it. Most of the vectors are going to be parametrically or component defined. So just be aware that if you write your vectors in IJ notation, nothing's wrong with that, and the readers will understand that and give you full credit for where credit is due. But most of the vectors are being defined in terms of parametrically defined functions. So what do you have to know? You have to know how to be able to generate the graph of a parametrically defined function on your calculator. That means change your calculator from regular y equals f of x function mode to parametric mode and do stuff in parametric mode. You'll need to be able to find and interpret the derivative of a parametrically defined function. And so that means we should be able to find x prime of t and y prime of t for a parametrically defined function as x of t, y of t. You should also know how to find the slope of a tangent line to a parametrically defined curve. In other words, you need to find dy dx, the same dy dx you've been finding from before we started using parametrics. And you need to talk about the second derivative of a parametric function, which is going to be a little bit more complicated than we kind of want it to be, but let's talk about that in just a moment. So the easy derivative is the first derivative. If you know parametric functions, you have two functions that are defined, one function defined parametrically, x of t, y of t, then dy dx is dy dt divided by dx dt. And if you think of these as fractions, you see that, I'm just going to write this like this so you can see it. If you treat them as fractions and multiply by the reciprocal instead of dividing the complex fractions, you'll see the dt's cancel. They don't really cancel, but let's pretend they do. And we left with dy dx. Now for the second derivative, you have to do a little bit more. Right? And the reason you have to do a little bit more is when you take the derivative with respect to x of dy dx, you're actually taking the derivative of something that's in t. Right? So you have to compensate for that t. And how do you compensate for a missing variable? I'm thinking you should be thinking about the thoughts of, say, chain rule or its equivalent, implicit differentiation. Because that's what's going to happen. In other words, that's where this dt dx is. You'll notice that right here, I'm actually doing the quotient rule, but because all of this is in terms of t and not x, I need to multiply by dt dx to compensate for the fact that I'm taking a derivative of a function only in t, and I want a derivative with respect to x. In other words, this is the first derivative with respect to t, and to make it with respect to x, I need to multiply it by dt dx. So dt dx is the equivalent of taking the reciprocal of x prime of t. So in other words, the second derivative of a parametrically defined function almost looks like the quotient rule, except that down here at the bottom you have x prime of t cubed instead of x prime of t squared. Now let's move on to motion in a plane. Motion in a plane is used, we use vectors for that. And so these are the basics for motion in the plane: position, velocity, acceleration, speed, and distance traveled. Very similar to the basics for motion along a line: position, velocity, acceleration, speed, distance traveled. And when we move along a line, we also talk about displacement. We don't talk about displacement in the plane very much, but you could. Displacement would just be a vector. Notice that position, velocity, and acceleration are all vectors, and speed and distance traveled are both scalars, aka numbers. Right? Speed's a number. It does not have both magnitude and direction, so it's just a number. Distance traveled is the scalar, just a number. It does not, again, have distance and magnitude only. It doesn't have length and magnitude and direction. That's the other one I'm trying to say. Only that number. Whereas position, velocity, and acceleration vector, you have to have two components in vectors, x and a y. So if you have the handout that I gave to teachers and you're ready to use that, we're going to go to that handout now. So the problem we're going to go to is from 2008. And if you're in the handout, you have to go all the way to the back almost to see this question. If you don't have the handout, hey, don't worry about it. Just follow along. Clearly, you'll see my question right here. And you can always get the handout later if you're a student at an AdvanceKentucky school, and they'll your teacher can help you with that handout. So this question is from the Form B exam in 2008. It was the exam given to folks overseas, that is not in the United States. It's a real exam question though, so we can go ahead and use it. It was number 1, which means it was on the graphing calculator portion of the exam, which means the calculator could be used, and in some places should be used or has to be used. So for 2008, Form B number 1, a particle is moving along the curve in an xy plane, and it has positions in x of t, y of t at time t greater than or equal to 0. With these two expressions, dx dt, dy dt equals 3 cosine of t squared over 2. Okay. So notice that we didn't give you the position function. We actually gave you the derivative of the position vector. And this is the notation they actually use on the exams. They just put parentheses around parametric functions. I like to write angle brackets. That's how I use vectors, so I didn't confuse vectors with an ordered pair per se, even though sometimes they're asking for the same thing. Here, since it's a calculator active question, the most important part you need to realize is that we need to see a setup and an answer that comes from the setup and answer. If you just write numbers without some sort of setup, you will not get full credit. Sometimes you won't get any credit for your answer. So let's start with part A. Part A, we want to find the acceleration vector at time t equals 4. Well, if that's position, that means that these give you velocity, so that's the velocity vector. And the acceleration vector at time 4 has components that are x double prime at 4 and y double prime at 4. Right? Now this is my setup. Right now I would go to my calculator and find the derivatives using my numerical derivative function to get x double prime of 4 and y double prime of 4. So I would suggest that if you're using something like a TI-84, TI-83, you store these as Y1 and Y2 and use X's, of course, instead of T's. And that way it'll be really easy to just do what you need to do, like in this case, find the derivative. You put this in your calculator and you find that your derivative is 0.4330, comma, negative 11.872. I'm writing wider than my screen is. So here's the important part, right? If I cover this up, if I only see that much, that will not get me full credit. If I only see this much, that will not get me full credit. I need the correct answer and some indication to the readers that, oh, and this is how I got that, without you defaulting to what I call calculator reads, telling me what buttons you push. I don't care what buttons you push as a reader. Don't show me the buttons that you push. Just show me how you got it, use calculus notation, and then give me the answer. In part B, now they want me to find the y-coordinate of the position of the particle at time t equals 0. Notice that they gave me the position at time t equals 4. So this is where you need to know the fundamental theorem of calculus very well. And what I tell my students, or used to tell my students when I still had my own students, was this: that the value that you want, which is the y-coordinate at time equals 0, is going to be equal to some value that you know, and we know what the y-coordinate is at time t equals 4 because they gave that to us, plus the net change between those two values. And net change is expressed as a definite interval. Here's my setup. This is the important part, right? They want to see, they being the readers, want to see that you know the fundamental theorem of calculus. Now, I'm going to go ahead and rewrite this, although I don't have to, just so that it's clear what I'm doing to you. 3 cosine of t squared over 2 dt, right? Here's the setup. Now, if you did follow my suggestion and put dy dt into y2 on your TI-84 calculator, then this is a piece of cake now. You could put it in here. Note that this is from 4 to 0, not from 0 to 4. They gave us 4. We want 0, so this is from 4 to 0. If you want, you can change this plus sign to a minus and make this go from 0 to 4 if you're uncomfortable with the bigger number being the lower limit of your integral. Another calculator tip: don't put this in stages. Put this whole line in the calculator at once. 5 plus the definite interval from 4 to 0 of y2 dx or du2, or depending on what kind of calculator you have, and you should get 1.6006. Now, since this is a graphing calculator active question, they will accept either 1.600, that is this number truncated, and you don't have to write the zeros in that case, or 1.601, which is this number rounded to the 3rd decimal place. Remember that decimal answers must be correct to 3 numbers after the decimal point. Let's look at part C. On part C, we are looking at the interval from 0 to 4. We want to know the speed when the particle first reaches, again, I retyped this, so I'm going to assume that the bad grammar is mine. Well, no, it's not bad grammar. I'm reading it wrong. At what time does the speed of the particle first reach 3.5? So what I think I need to do is this. Okay, I want the speed to reach 3.5, so I need the speed to be equal to 3.5, and I want to know when that happens. Speed is going to be the square root of dx dt squared plus dy dt squared. I hope I'm not confusing you too much by switching my notation. I know earlier I wrote x prime of t, y prime of t, and now I'm writing dx dt, dy dt. I switch back and forth. The exam does too, so you'll want to be comfortable with switching back and forth. And we need this to be equal to 3.5. So from this point, I would go straight to my calculator, right? The way I would solve this is I'd be in function mode, not parametric mode. I'd put in the speed expression into, okay, my y1 and y2 are occupied right now, so y3, and 3.5 into y4, and see where these two lines intersect for the first time. Luckily for you, I have prepared a picture, and I hope you can see it. You can see that, right? So here's my speed expression, right? dx dt was the square root of 3t, and dy dt was 3 cosine t squared. Now these have x's because I graphed them in the function window and not the parametric window, so that's why they have x's, but that's the speed expression. The red line's 3.5. Notice that it intersects more than once, but the first time it intersects here is here at about 2.23. I'm not going to be happy with 2.23 though. I need to make sure that I get that number to the correct number of decimal places. But I wanted to give you an idea of how to solve this. I could have adjusted my screen to show you 3 decimal places, but frankly, I printed this off at the last minute because I really wanted to show it to you, and it wasn't showing up very well on my calculator itself. I have it. See, but the screen on my calculator wasn't showing up very well, so I decided to recreate this on my laptop and then print it out. So that 2.23 is actually to 3 decimal places. T equals 2.226 if you round it. Notice I don't have to show how I'm doing anything. This is a graphing calculator active question, so I need to show a setup, and then I can go straight to the answer. This number, by the way, truncates to 2.225, so they would accept that also. I'm running out of space, so let me just write this at the bottom of this. Looking at part D. Part D says to find the total distance traveled by the particle over the time interval from 0 to 4. So I'm going to slide this up a little bit so you can follow along. So for part D, distance traveled, I integrate speed from 0 to 4 of the square root of dx dt squared plus dy dt squared dt. There's my setup. I put this in my calculator. Now remember, if you had done what I suggested before with your 82,304 and put that in y1 and that in y2, you could just do y1 squared plus y2 squared and not have the problem of possibly typing something in wrong. And this is going to be approximately equal to, but we're going to say equal to 13.182. And that rounds and truncates to the same number. So here's my setup and my answer. Think about that anytime you're doing stuff on the calculator part of the exam. We don't need to see a lot of intermediary steps. We know you're going to use your calculator. One of the 4 things you need to know how to use your calculator for is to evaluate a definite interval. Another of the 4 things you need to know your calculator for is to be able to solve an equation. And one of the other things you have to use your calculator for is to be able to find derivatives numerically. So I'm actually using 3 out of 4, 4 if you include that I use graphs to solve that, of the 4 calculator skills in this problem. Let's talk a little bit about how this is scored, and I actually have this printed out separately. This is a clip from the scoring rubric, right? So number 1, the number 1, that answer is only worth 1 point. You're going, what? I thought you said you had to show me a setup. And I do, right? If I just have this, even though that is the correct answer, I don't have any calculus on top of it. We want to graph calculus. We don't know where these numbers came from without at least a label. So you will not get the answer point unless you had some kind of labeling on here that shows us where those two numbers came from. And both of them have to be right. You can't get we don't give half points. And part B, we wanted 4 points. They're actually 3 points. I'm looking at the 4 and saying 4, right? So the first point is for the integrand. Okay? It's not an integrand if it's not in the integral, y'all. So make sure that it's in a definite integral. But that first point is for realizing that that's what you want to integrate. 1 point for realizing, you know what, I need to put a 5 in there. Notice that it says y of 4 equals 5. So it's got to be a number 5, not just y of 4. Well, actually, you could do just y of 4, right? Because we told you that. And the last point is for the answer. Well, a lot of times they give us a limits point. So, yeah, but if your limits are wrong, your answer's wrong. Sometimes they give us an integral point. Yeah, but in this case, you want to make sure that the integrand's right. And if it's not, again, your answer will come out wrong. So all of that other stuff comes out in the wash. In part C, I feel like I'm talking really fast, and if I am, I apologize. But for some reason, I'm really hyped, and I have had no caffeine, so what's that about? I guess it's just because it's a beautiful day outside, and I really want to get finished. Here's my speed expression. Right? You don't get the point really for writing this down. You get the first point for writing that down. The square root of 3t plus 9 cosine squared t squared over t. Right? 1 point for the equation, right? Setting this equal to that. And then 1 point for the answer, t equals 2.225 or 2.226, depending on whether you prefer to round or truncate. And finally, the last point, part D, is for the integral. Now notice this says integrand up here. This one actually says integral. So it includes the limits from 0 to 4. It includes the integrand. So all of this has to be right to get that first point. And then the answer is the answer. We don't need to see anything in between. I hope you don't even attempt to actually evaluate this definite integral by hand, because it's not a skill that you've learned in AB Calculus BC most likely. So I went through that example. Let's look at another one, which is also in the packet. It's right after the one we just did. Right? This is from 2007. It's also from the Form B exam, the overseas exam. And this one was number 2. So there was also on the calculator portion of the exam. A particle moving along a curve in the xy plane has position x of t, y of t. And at time t, with dx dt is equal to that inverse tangent thing, and that dy dt equal to that natural log thing for t greater than or equal to 0. That's good because, you know, at time t equals 0, the object is at position -3, -4. And there's a note that inverse tan x is equal to arctan. According to some texts, not many anymore, but there's some folks who think that arctan and inverse tan are not exactly the same thing. But as far as the AP exam is concerned, inverse tan, looks like an exponent of -1, and arctan are the same function. So for part A, we want to find the speed of the object at time t equals 4. This is starting out pretty much exactly like the other one did. So speed is equal to the square root of dx dt squared plus dy dt squared. And at t equals 4, that means the speed is equal to the square root of arctan of 4/5 all squared plus ln 4 squared is 16 of 17 squared. Now, actually, I can stop right there. That is a perfectly good answer for the speed. Right? Most students did not stop there. They went ahead and evaluated it. But Once I have plugged everything in like this, put the functions and the numbers in, I'm really done. So that's a good test taking skill. Try not to do more work than you have to. That's not the same for here. That doesn't help me. And if I use X prime and Y prime notation, that's not good enough. But this is fine. But most students went ahead and evaluated this, and hopefully they correctly evaluated it to 2.912. Again, a test-taking strategy that I think is a good one. In fact, if you're using a TI-84-ish type of calculator, I'd put x of dx dt in y1, dy dt in y2, and that way when I'm down here, this is just y1 squared plus y2 squared, and I can just put in the 5. Right? Actually, it's y1 of 5 squared. You know what I'm saying? What I'm saying is, if this is y1, then this is y1 of 5 squared plus y2 of 5 squared square root. That'll give me the speed that I want. Well, it helps if you can see it, right? That will give me the speed that I want without me retyping. The reason I don't suggest retyping everything completely every time is that sometimes you type things in wrong, which throws your answers off, especially if you're one of those students who are not very good at parentheses. By the way, this square is outside the parentheses, not inside. I'm squaring the whole thing, not the 5. Part B wants me to find the total distance traveled by the object. I mean, come on, it's the same questions over and over again, right? So to find total distance, I need to integrate the speed. So this is going to be the square root of, I'm just going to write dx dt squared plus dy dt squared with respect to t. And notice that on the actual exam, you could write this, and this would get full credit for the integrand, or if it was an integral point, you get full credit for the integral, since the exam has defined dx dt and dy dt as these two functions. In other words, you don't have to write the functions over again if you don't want to. At this point, I put it in my calculator again, and this time I'm going to get 6.423. Notice too, even though both of these questions were calculator active, all 9 points didn't involve use for the calculator. In fact, on the last question we did, I'm glancing back at it, 1, 2, 3, 4, 5 out of 9 points were no calculator points. Part C, find x of 4. Well, last time we found a y coordinate. This time we're finding an x coordinate. So what did I say again? That the value that I want is equal to some value that I have. And remember that they told me what the position was at time 0. So I actually know x of 0 plus how much x changed from time 2 to time 4. X of 0 is -3. And dx dt is the arctangent function they gave us up top. And again, I would not do this separately, right? If I had this stored y as y1, I would just say y1 and dx on my calculator and say -3 plus the integral from 0 to 4 of y1 dx and get my answer, which should be -0.892 rounded or truncated. You remember that on the calculator portion of the AP Calculus exam and free response, your answers must be correct to 3 numbers after the decimal point. Rounded or truncated, but 3 numbers after the decimal point. If you do not write that, you will lose points on your exam. Now let's look at part D. And part D, I'm scared to cover up part C and know about part D. All right, for for some positive value of t, there's a point on the curve where the line tangent to the curve has slope 2. And at what time t is the object at this point, find the acceleration vector at this point. So there's a lot of stuff going on here for d. So slope 2, line tangent to the curve, slope of a tangent line, dy dx. dy dx is equal to 2. How can I find t? That doesn't help. But remember a little earlier I told you the relationship parametrically with dy dx? I said it's kind of a chain rule thing. Is dy dt divided by dx dt. So dy dt is this arctan function. I'll go ahead and write it down. Nope, I'm upside down. So dy dt is the log function, and dx dt is the arctan function. Sorry about that. I do that all the time, actually. Luckily, most of the time I catch myself. And this is going to be equal to 2. So one of the 4 things you need to know how to do on your graphing calculator, solve an equation. So what I would do is I would put this as one of my y functions, use x's instead of t's because I'm in function mode. And I'd put this in another one, see where the 2 lines intersect, and find the point of intersection. Now this time I didn't create the graph for you, so I'm just going to tell you what this answer comes out to be. T is equal to 1.35766. So that's the first thing. Find the time that this stuff happens. And then after the question mark, they ask you for the acceleration at this time. Well, that means that you want for the acceleration at this time, 5, 8. Here's another note. If I'm going to use this value to get this acceleration, I do not want to use a rounded value. In other words, I don't want to round this to 1.5358 or 357 and put that truncated or rounded number in. I want to save all the decimal places. So you should learn, if you haven't already, how to store numbers in your calculator. That way you could take the stored number with all of the calculator's decimal place and put it into x double prime and y double prime. Okay, so that's how I'm going to find my acceleration vector. I'm not done yet. I should not have variables in my answer. I should have numbers in my answer in this case. So my acceleration vector actually is, and again, I'm not going to take the time to put this in my calculator. I'm assuming you pretty much know how to do that. So there's my final answer. So altogether, here we are doing speed. Well, there we are doing speed at part A. We got a speed of 2.912. Here we are integrating speed to get distance. Notice that if we're doing motion along a line, we still integrate the absolute value of v, speed, to get distance traveled. So I like to characterize the 2 things in similarities with motion in a line and motion in a plane. In part C, we had to find the x-coordinate in time t equals 4. And in part D, we had to find out when the slope of the tangent line is equal to 2, at what time, and then find the acceleration at that time. So here we go. Looking really quick at the scoring rubric. Here it is. This is an example of the scoring rubric. Your teacher can find this very easily. It's not hard to find. It's available to the public. So the speed here, you got 1 point for that speed, but oops, you can't see that speed. There you go. You get 1 point for that speed of 2.912. Again, if all you write is this number, you don't get that point. It has to be dressed up with some sort of setup. Setup, answer. Setup, answer. Setup, answer. Setup, answer. So it's very important that you show that kind of stuff. That's a general rule. If you don't remember anything else, well, you should remember a lot from this video, right? But you should remember that. So 1 point for the speed, 2 points, 1 for the integral for distance, and then 1 for the answer, 6.423. Part C is worth 2 points. There's 1 point for the integrand, not the integral. So that's for realizing that you need to integrate x prime of t, dy dx dt. And for using x of 0 equals -3. So that's 2 points. And then the answer is the third. 2 points for the setup, 1 point for the answer, 1 point for the setup, 1 point for the answer. And in part D, dy dx is dy dt divided by dx dt, and we want to set that equal to 2. They've gone ahead and written this as without the fraction. I didn't do that, but it doesn't matter, right? You get the first point right here, where it says dy dt over dx dt is equal to 2. That's what you get the point for. You get the second point for getting the t-value of 1.35766. Right? This is not a final answer, so if you show more or fewer decimal places, I mean, don't get crazy and say it's 1, right? It doesn't matter because it's not a value that we actually add. Yes, oh, I take all that back. We did ask for that time. So it needs to be correct to at least 3 decimal places. Notice that they wrote more than 3, not a big deal. If all you write is 3, 1.357, or 1.358, we'd be cool. And then values for x double prime and y double prime at this time to get the acceleration vector. You don't have to go back and write it in this notation. I know I did it, and it did it on the scoring rubric. But if you just write something like x double prime of that number is equal to 0.135 and y double prime of this time is 0.955, and never put it all back together nice and pretty, we would give you full credit for that, we being the readers of the exam. So I always like to follow up some free response with some multiple choice. Again, your teacher has access to the handouts if you're a student at an advanced Kentucky school. So please take advantage of that. If you already have the handout, right before these 2 free response questions that were at it, right after, I think, because I think the multiple choice is actually at the end of this handout, you'll see these multiple choice questions. So I'm going to go through them. I'm not going to bother to check my Twitter while I'm talking because I found that that was nearly impossible for me to do. So what I'll do is I'll check my hashtag later on, or after I get off the presentation. And you can always just directly email, tweet, hashtag tweet me, Monique Morton, at Monique_Morton on Twitter, to ask any questions. So for part A, they ask us, number 1, time t equals 0, particle moving in the xy plane is given by this velocity vector. What's the acceleration vector? Well, even without doing any work, you know to eliminate d and e, right? Those aren't vectors, they're scalars, so we know that's not right. And I'm looking at this and I'm going, okay, well, if that's v of t, then the vector a of t is going to be equal to 2t, 5, right? The derivative of t squared and 5t. Only one of those has a 5 at the end, so I don't really have to do any more work to see that my answer should be B. But if I wanted to check, if I put 3 in for t, that gives me 6. I'm even more convinced. No calculator needed. I'm done. Number 2, length of the path is the same as distance traveled, right? If you're moving along a path, its length is how far you went. So the length of the path for parametric equations is the same as distance traveled. So that means it's the square root of dx dt squared plus dy dt squared. Length of the path is the same as distance from 0 to pi. So I look and I go, okay, wait. So this would be, let's see, if this is x, then dx dt would be 3t squared cosine t cubed using the chain rule, right? Think about that for a moment. That I'm doing it in my head one more time to make sure I wrote this down right. Yeah. And the derivative of e to the 5t would be 5e to the 5t. And I'm squaring that. So to find the length of the path, I'm going to go from 0 to pi dt of this. So I just have to figure out which one matches. It's not that one. It's not that one. I think it's this one. Clearly not that. I double check and remind myself that I'm squaring. So this should be 9t to the 4th. It should be 25e to the 10t. My answer is C. Multiple choice questions vary in difficulty. Just because it's number 1 doesn't mean it's necessarily the easiest one, although it's probably going to be easy. Just because it's number 15 doesn't mean it's the 15th hardest question. The questions vary in difficulty, so just because you can't do one doesn't mean you can't do the next one. You should actually, I think, work through all the problems that you know how to do first, and then go back and work on the ones you think you know how to do. Right, that's the end of 1 and 2. Let's look at 3 and 4. In the xy plane, a particle moves along a parabola. The parabola is the path of movement with a constant speed of 2 square root of 10 units per second. If dx dt is greater than 0, what's the value of dy dt when the particle is at the point 2, 2? Well, what I'm going to say is this. Well, speed, start writing up here, right? Speed is dy dt squared plus dx dt squared. And that's going to be equal to 2 square root of 10. You can't see anything I just wrote. Okay, there we go. So if I differentiate this equation with respect to t, dy dt is equal to 2x minus 1 dx dt, right? Think about it, think about it. This is dy dx times dx dt, so it leaves me with dy dt. So if I square this and plug it in here, I'm not going to go through all of the steps, but this is what we're going to get. Square root of 2x minus 1 squared plus 1 is equal times dx dt. Right, so I'd have a dx dt squared over here and a dx dt squared in here. So I factored out the dx dt squared square root equals 2 square root of 10. So I'm thinking that dx dt is 2, and the stuff under the square root is 10. 2x minus 1 squared plus 1 is equal to 10. Okay, so I want the value of dy dt when this is equal to 10. So dx dt is equal to 2, and this is 2 times 2 minus 1. That'll be 3 times 2, which is equal to 6. Now I'm going to check because I think I have the answers around here somewhere to make sure I have the right answer. I'm not too confident in myself with that problem. Yay, I am right. I was going to do some more work here and then realize I don't need to do that. If I just said the dx dt is equal to 2, man, I could just start plugging stuff in and get my answer. So there I go. Make my answer to number 3 is D. So I didn't need to do this part right here. I just made these parts equal. Dx dt is equal to 2 because the square root should match the square root. The square root should match the square root, so that means the dx dt is equal to 2, and I'm at the point 2, 2, so I put 2 in for x and 2 in for dx dt, and man, there's a lot of 2's going on here, but 4 minus 1 times 2 is 6. Number 4. Now, this is a calculator active question. So I want to know if you could see my calculator. Maybe I could try it. Maybe. So a particle moves in the plane so that its position at any time t is given by x of t equals t squared and y of t equals sine of 4t. What's the speed of the particle when t is equal to 3? So we need x prime of t, and we need y prime of t, because the speed is going to be at the square root of 2t, in this case t is 3, so 6 squared, plus 4 cosine of 3 times 4 is 12, all squared. And so this is the square root of 36 plus parentheses. Oh, let me put my 4 in there first, and now put the trig function in. Cosine of 12 squared 6.88429. I hope you can see all that. 6.884. The answer to number 4 is C. This isn't really so bad, right? Once you get the idea of motion and speed and everything like that, these questions go pretty quickly, I think. Speed, as you can see, speed shows up a lot. So does distance travel, which is related to speed. Remember that distance travel and arc length are the same thing. So once you have all of that down in general vector valued functions, you know, that we're using parametric functions to represent our vector functions, I think this topic is pretty, in this general scheme of things, not that hard. I hate saying not hard. Somebody's going to call me out on that. But, you know, there are harder things in life, right? So f is a vector value function defined by f of t equals e to the negative t cosine t. Don't let the phrase vector valued function mess you up. It's a vector defined by two functions, e to the minus t and cosine t. Define the second derivative, well, just like you would with a regular function. Define the second derivative. First, you find the first derivative. And then you find the derivative of that. Now, you know it can't be A and it can't be B because vectors don't magically become scalars by taking their derivatives, right? They're still vectors if you take derivatives. So let's see, the second derivative then is e to the minus t minus cosine t. Notice that all of these questions so far, except number 4, could appear on either, wait, let me check. Yeah, could appear on either calculator or no calculator. So understand that it can be either way. Some of these questions would be strictly no calculator because a calculator will make them too easy, like this one. Not easy for everybody, but somebody has what I have. See the letter CAS up here? That means it's a computer algebra system. Literally, I can put that in my function, put it in my calculator, push a couple of buttons and get the derivative without having to know how. And number 6, the XY plane. we have a graph of the parametric equations, and they give them to us. And it's a line segment with slope blank. Well, if this is a line segment, its slope is the derivative, dy dx, right? Because a line segment, its slope is a constant. The constant happens to be the slope of that line. So I hope that made sense to you. That's going to be equal to the derivative of y, which is 3, and the derivative of x, which is 5. So the slope is 3/5. It gets a line, right? A line segment's slope is its derivative because it's its own tangent line. Couple more, and then I'm going to stop. In fact, probably after these two, I'm going to stop. So number 7, a particle moves along a plane curve so that any time t greater than 0, its x-coordinate is t cubed minus t, and its y-coordinate is t minus 1 quantity cubed. What's the acceleration vector? So these are the two components of the position vector. So the velocity vector is going to be equal to the derivative of t cubed minus t, which is 3t squared minus 1, and the derivative of 2t minus 1 cubed, which will be 3 times 2, which is 6, times 2t minus 1 squared. And the acceleration vector would therefore be the derivative of those components. Derivative of 3t squared minus 1 is 6t, and derivative of 6 times that quantity squared is 2 times 6, which is 12, times the derivative of the inside function, which is 2, so that's 24, times 2t minus 1. Plugging in 1, I get 624. So the answer to number 7 is E. I'll take those derivatives right. This is 3 times, and the derivative of inside function is 2. Yeah, I think I'm good. And number 7, the length of the path. The length of the path, that again is the same as distance. If a particle was moving along that path, the length would be the same as distance traveled. So the length of the path is, well, these are the positions, the derivatives, x prime and y prime would look like that. So we want to take x prime squared plus y prime squared, just take the square root of that, t to the 4th t squared, from 0 to 1. So there's some more multiple choice questions in here. I'm looking to see if there's anything that's really, really unique that would be worthwhile me doing right now. Nothing that jumps out at me. So let me go back here. So parametric functions and vectors are going to show up on the BC exam. It's one of the things that distinguishes the BC exam from the AB exam. It'll show up in multiple choice. It may or may not be a free response question. It kind of depends on what happened last year. If last year had a polar problem, then this year would be a motion problem, most likely, or vice versa. But that's not always true, so don't bet your money on it. It's important to understand the background on it. If you need more review, I suggest spending some time with your teacher. They'll probably review this in class. If you have questions on this or anything else in the handout or anything else that I said today, you can catch me on Twitter and use the hashtag AskMoniqueKY, and I promise to check them a little later on. I'm not checking now. I'm about to check out of here, go home, get some dinner, and chill, and hope that there is a new episode of Supergirl tonight. Is there a new episode of Supergirl tonight? I certainly hope so. Anyway, Thanks for watching, if you're watching. Bye-bye.